Welcome you all to NRS మంచి మాట తరగతి గది presented by NRS Thoughts. In this video, let's have a detailed discussion on even and odd functions and their properties. There are different types of functions in mathematics we study. Even and odd functions are also such two different functions. We can use algebra and graphics to define even and odd functions. Now let us define even and odd functions graphically. Let us first define even function graphically. The graph of an even function is symmetric with respect to y-axis. That is, its graph remains unchanged after reflection about the y-axis. Let's now take a look at this graph. Does this graph represent an even function? If you look back at the definition of an even function, it tells us that the left half of the graph should match the right half. In this case, both sides of the graph match one another. That is, the graph is symmetrical about y-axis. Therefore, this graph represents an even function. The equation of this graph is y is equal to mod x. This is another example of an even function f of x is equal to x square plus 1. Please look at its graph, which is clearly symmetric about y-axis. Let's now define an odd function graphically. The graph of an odd function has rotational symmetry with respect to the origin, meaning that its graph remains unchanged after a rotation of 180 degrees about the origin. That is, the graph of an odd function is at an identical length from the origin taken in the opposite directions, or for any two opposite input values of x, the function will hold the opposite value on the y-axis. Now let's take a look at the graph of the function f of x is equal to x cube minus x to understand the graphical definition of an odd function. We can see the graph of the function f of x is equal to x cube minus x in the figure 1. Now let us rotate the graph given in the figure 1 90 degrees about the origin. After 90 degrees rotation about the origin, we get the graph given in figure 2. We can observe that the graph of figure 2 is not same as the graph of figure 1. Now let us rotate the graph given in figure 1 180 degrees about the origin. After 180 degrees rotation about the origin, we get the graph given in figure 3. Now we can clearly observe that the graph of figure 1 and the graph of figure 3 are the same. That is, the graph of the given function remains unchanged after a rotation of 180 degrees about the origin. That is, the graph of the given function has rational symmetry about the origin. Also, we observe that this graph is at an identical length from the origin in the opposite directions. Moreover, we can see that for two opposite values of x, the function has two opposite values on y-axis. Therefore, this graph represents an odd function f of x is equal to x cube minus x. In this way, we can tell whether a function is odd or not by looking at the graph of that function. This is another example of an odd function f of x is equal to x. Please look at its graph, which is clearly symmetric about the origin. Let's now discuss another case of functions which are neither even nor odd. If the graph of a function is neither symmetric about origin nor about y-axis, then such function is neither even nor an odd function. Now let's look at the graph of f of x is equal to x cube minus x plus 1 to understand the concept of neither even nor odd. Let's first verify whether this graph is odd or not. This first graph is the graph of the given function f of x equals to x cube minus x plus 1. The second graph represents 90 degrees rotation of the first graph. This 90 degrees rotation is not having any importance in finding odd function. This third graph represents 180 degrees rotation of the first graph. We can see that these two graphs are not same. That is, the graph of the function f of x equals to x cube minus x plus 1 is not symmetric about the origin. Also, we can see that this graph is not at an identical length from the origin taken in the opposite directions. Therefore, this function f of x equals to x cube minus x plus 1 is not an odd function. Now let's verify whether this function is even or not. Look at here, the left half of this graph is not matched with the right half of this graph. That is, this graph is not symmetric about y-axis. Therefore, the function f of x equals to x cube minus x plus 1 is not an even function. Hence, the function f of x equals to x cube minus x plus 1 is neither even nor odd function. Now let's comparatively discuss the three cases of even, odd and neither even nor odd to understand well. First graph represent the graphs of odd functions as they are symmetric about the origin. Second graphs represent the graphs of even functions as they are symmetric about y-axis. Third graphs represent the graphs of neither even nor odd functions as they are neither symmetric about y-axis nor about the origin. Let's now see some more examples of even, odd and neither or cases. This graph represents sine function which is symmetric about the origin. Therefore, sine function is an odd function. This graph represents cosine function which is symmetric about the y-axis. Therefore, cosine function is an even function. This graph represents the function f of x is equal to x cube plus 2x square minus x, which is neither symmetric about the origin nor the y-axis. Therefore, this graph is neither even nor odd function. Let's continue our discussion on even and odd functions in the next part 2 video of even and odd functions with algebraic approach. Until then, my best wishes to all.